Good morning everyone. Today we will learn about counters. It is a part of digital electronics. So at first we know about what is a counter. Counter is a digital subsystem used in computer for counting binary numbers. Binary numbers means 0 and 1. Then another definition of counter is a sequential circuit that goes through a prescribed sequence of states upon the application of input pulses is called a counter. Means these are the pulses. This part is 0 and this part is 1. So the number of pulses we have to count. In a counter, the sequence of states may follow a binary count or any other sequence of states. Means this is one state, this is one state. 0 state is one state. The change of states 0 to 1, then 1 to 0. These are the state change. Counters are found in almost all equipment containing digital logic. Means the parts which are in digital logic we may find a counter. In counter, we will count the number of occurrences used in the pulses. Means how many occurrences are there in a counter. We will count them. And by counter, we will also generate pulses. In how many timing sequence we have the counter. In various sequences, a counter may follow the straight binary sequences in the simplest and most straightforward state. A counter that follow a binary sequence is called binary counter. Means if a counter follows the binary sequence it is called a binary counter. A counter with n flip-flop can count in binary from 0 to 2 to the power n minus 1. That is 2n states, which is known as the modulus of the counter. What is modulus of counter? A counter with n flip-flop means n number of flip-flop. can count in binary from 0 to 2 to the power n minus 1. By this, we will found the modulus of the counter. Means it may be modulus 2, module 1, module 5, module 10. The n number by counting the n number of flip flop, we can find the modulus of the counter. Then the counters are divided into various types. Means synchronous counter, asynchronous counter. Classification of counter. Counters can be classified into two broad categories. One is synchronous, another one is asynchronous. The asynchronous counter are called ripple counter. Ripple. These are called ripple counter. In asynchronous counter, the first flip flop is clocked by the external clock pulse. In this case, the first flip flop is clocked by the external clock pulse, and then each successive flip flop is clocked by the Q and Q bar output of the previous flip flop. Means what we know about the asynchronous counter. पहले तो फर्स्ट फ्लिप फ्लॉप इज क्लॉक्ड बाय द एक्सटर्नल क्लॉक. फर्स्ट फ्लिप फ्लॉप is clocked by external clock pulse. Then each successive flip flop is clocked by the Q and Q output. Means whatever the first flip flop, it will be clocked by external clock pulse. Means we have to add another clock pulse for the first flip flop. Then simultaneously other flip flops are to be clocked and the output Q and Q bar is out. Simultaneously the other flip flop are pulsed by Q and Q bar of the previous flip flop. Means if we take what in asynchronous, the first flip flop is pulsed by another, and the simultaneously other flip flop are clocked by the output Q and Q bar of the previous flip flop. Then we will learn about synchronous counter. In synchronous counter, all memory elements are simultaneously triggered by the same clock. Here, same clock is used. Same clock is used. In asynchronous, different clock poles are there and different flip flop are used. But here, same clock is used for triggering. Depending upon the counting sequence, we have two types of synchronous counter. One is up counter, another one is down counter. So, synchronous counter is divided into two types: up counter, then down counter. But what is up and down? You may be thinking that up means towards up and down means towards down. Not that type of. Up means if the counter counts in such a way that the decimal equivalent of the output increases. What means the decimal equivalent of the output increases with successive clock pulse. It's called up counter. And if this is for up counter and for down counter, what happened? The decimal equivalent of the output decreases. In both the counter, we will take the decimal equivalent of the output. In up counter it increases, in down counter it decreases. So this is all about this synchronous, asynchronous and up and down counter and all about counting. In the next class we will learn about the 4-bit asynchronous up counter. If in this case if you have any doubt, then communicate me and we will do it in the next class. Asynchronous 4-bit asynchronous up counter. It is in up counter it will also asynchronous ripple counter, 4-bit ripple counter is there, successive approximation type counter is there. So there is a huge part of counter. We will discuss it regularly. Thank you.